Hello, everyone, and welcome to another Tour Tuesday. As some of you may know, this is our farewell series. So this is the very last season of Tour Tuesdays that we will be doing. However, we will go back to in-person tours, which we are really, really excited about. So for those of you that have tuned in and like the virtual tours, there's a ton on the YouTube channel that I'm sure you have not seen. And we will also be scheduling some in-person tours with different schools. So stay tuned. Today we have Evergreen Engineering, which is a local engineering firm. Thank you all for being here. I'm going to start actually by asking Cody to introduce himself, and then maybe you could tell us just a little bit about your role at Evergreen.
Sure. My name is Cody Kenny. I am a civil engineer by degree. My position is the engineering manager at Evergreen, and I'm a principal in the firm.
What does that mean? A principal?
So, well, yeah, a principal means that you're one of the owners of the firm.
Wow, okay.
And
Great.
so as an engineering manager, I have 4 department heads that report to me. And that includes our mechanical department, our electrical, our structural department, and then our CAD or drafting department.
Okay, great. Thank you. And Derek.
Hello, everyone. I am a mechanical engineer and project manager here at Evergreen. My main role at Evergreen has actually been, besides being an engineer and doing the technical side of things, I've actually done a lot of mentorship for interns, working with the younger engineers or the engineers in training. And in addition to being a manager for the various projects that we have, I usually am in a lead mechanical role within those projects. But my background, as far as my engineering school bachelor's degree, is in mechanical. But I really enjoy doing a little bit of teaching, and I like the technical stuff. So
that's awesome. Well, thank you for joining us. And then John, who unfortunately cannot turn on his video, but he is here to talk to us. So John, go for it.
Yes, thank you. Hello, everyone. My name is John Meshnick, and I am an electrical engineer here at Evergreen Engineering. I'm been here for over 30 years. And I too, as with Derek, have filled a mentor roleship here with the MECOC program in the state. And my primary work here is to do power and control engineering for Evergreen, as well as project management roles as they show up.
Power and control engineering, what does that mean?
So when you have things that are electrified out there in the world, okay, you have to get the electricity to them. But once you do that, then you have to make sure that they operate properly, right? They go on and off when they're supposed to, and they ramp up and down as they're supposed to do. You know, the lights go on in a certain section, go off in another certain section. So that's kind of the controls aspect of it too. So we're not only providing the power to them, we're also providing the infrastructure to control them.
Okay, power and control, that makes sense. All right, so Cody, I guess we'll start with you. Can you just talk briefly about your pathway into this career, and maybe start with your schooling so that we have a better understanding of what certificates or degrees you needed to kind of get your foot in the door?
Sure. This is going to be a little bit similar for all of us, but maybe each have their own nuances. So I started out, I went to community college. I went to Central Oregon Community College in Bend, and got my Associate of Science there and Associate of Arts, and transferred that to Oregon State University, where I got my bachelor's in civil engineering, and that's a bachelor's of science, of course. And in that process, I was actually an intern in the MECOP program that John had mentioned earlier. For all of you considering an engineering pathway, I strongly urge you to look into that when you get into your freshman or sophomore year of college. And then as part of that program, you go out on 2 full-time 6-month internships. So I had that opportunity, and then I was hired by one of the companies that I did an internship for, and that happened to be ATI. alloys and components up in Albany, and I worked there for 7 years as a project engineer and doing engineering projects out in their industrial plant. And then I came to Evergreen as a staff level structural engineer and worked doing that, and became a department manager, and then a principal, and then changed my role more recently to the engineering manager.
Okay, thank you.
Yep.
Eric, what about you? Any differences there?
Yeah, I mean, I didn't do the community college route. I grew up in Corvallis, and basically my senior year in high school, I was applying to schools, and it's like, if I wanted any help paying for anything, it was gonna have to stay in state.
Mm-hmm.
And so I was looking at different options, and I really liked working on cars, as high school boys sometimes do, and girls and everybody. But that was the thing at the time that we were kind of into, and I thought, oh, a mechanical engineer is like, that's like what they do. And then I didn't really understand mechanical is a little bit broader than that. So when I went to, so then I looked at going to Oregon State, applied and got in, and had decent grades and got a little bit of help, but for the most part just went straight through Oregon State, 4 years and a term there, and learned what mechanical engineering was sophomore year. It kind of hit me, and I was like, oh, this is actually challenging, and I not what I thought, and I ended up kind of focusing and really enjoying more of the energy kind of flow part of mechanical engineering, more than even the machine design. I actually liked some other aspects of it more, and heat transfer and things like that. And so I kind of focused on that my last 2 years, but didn't really know what I was going to do, other than just I knew I wanted to get this degree, and I enjoyed learning the stuff that I was learning. And then a family friend worked at Evergreen and said, hey, you should apply because you're qualified for, starting out. And I applied and got the job, and started off as a kind of a designer drafter role, and learned a lot about, you only learn a little bit of that in college. And that was really, really a good experience, was learning how to be a good draftsperson, and understanding how to take ideas and actually put them into instructions, and conceptualize a 3D set of instructions into a drawing that you can communicate to somebody to go build. And that was a process that was also sort of a steep learning curve, but really valuable for an engineer later on, even if you don't do much drafting as an engineer.
Sure.
These instructions, as I say, like, they need to be communicated to somebody to build anything, and just understanding that is really really important. And so that was kind of just an on the job training to some extent, but was exposed to a little bit of it in college. And I think at most colleges they try to get people familiar with that, but it's so software heavy that you sometimes you need to be understanding things outside of the software if you really want to use it effectively. And so that's just comes from experience, really. And then but I really enjoy the consulting world. I stuck at this company for a while for a reason. I really like the consulting world because you're working on different projects all the time, and I get to use my kind of broad mechanical discipline in a multitude of ways. So.
In consulting, meaning you're dealing with the client themselves to learn what they want, and to kind of go back and forth.
By definition, we are a consulting firm, meaning that the way our organization is structured is we get hired to do on a contractual basis to do projects, and those projects are based on what our client does, and oftentimes those are industrial manufacturers. Sometimes they're commercial. Sometimes we've designed things for schools, whether it's like sprinkler systems or something like that. So the nature of the way the business is structured is really what makes it a consulting firm. And our product is our service
Yeah.
essentially. And our service could be drawings, calculations, a number of things like that.
Got it, because we're dealing with safety. So if I was part of a school board or a school team, I wouldn't want to draw out the like sprinkler plans on my own.
Yeah,
Like
I
that's
think
the professionals.
it probably would be illegal to do
Yeah,
that.
probably. Yeah. We talked a little bit, or I saw in the video that you all talked a little bit about making sure things are up to code and following all of those rules. And so I'm sure you're the experts who know them best. But I want to touch on something really quickly before we get to John. But you mentioned CAD drafting and how that kind of got you in the door. And if you didn't have the aspirations to be an engineer, you could just get an associate's degree and be a CAD drafter as a job, like a career. I know that there are really large teams of CAD drafters.
Absolutely. Yeah. I mean, we have one person here. Well, we have lots of people here, but one person in particular that just comes to mind because I'm working with them right now. She's an excellent Revit, which is the software that we use, Revit user, but she has a really good ability to not just know the program really well, but also know how to communicate to the reader of a drawing, or what they ultimately see. Because especially now, back in the day, you'd have to draw the stuff on a piece of paper, and you'd have to imagine the 3D space in your head, and then draw that thing. And I'm kind of like an old millennial, so I'm like on the cusp of that. But now with 3D software, it's so much more powerful, and the ability to check things ahead of time, really see these conflicts, in terms of like something running into something else, or dimensions. In 3D, you can do a lot more with it. It's a lot more powerful. But like anything that's a tool, it has to be used properly. And just because you can see it in the 3D space, you still have to turn it into a set of instructions, and that's the challenge. And communicating to the client how, I always tell people, when a young drafter or designer or engineer comes to me with a report or a drawing, and I say, like, I've been working with you for hours on this thing, and I can't quite follow this. It tells me that a person who's never seen this at all is really not going to be able to follow it.
Totally.
So that's a really good kind of real quick check on, hey, am I communicating what I've been playing around in this 3D space for hours? Does it actually translate?
Totally. And we talk a lot on, we do something called Working Wednesdays, which always follow our Tour Tuesdays. And we kind of dissect different professional skills, and communication comes up constantly. But that feels like a whole new form of communication that we don't really think about, which is being so articulate that you can communicate like an entire idea in a set of instructions. So that, I feel like that takes a very special person and a specific skill set. Very cool. All right, John, sorry to leave you hanging. Can you tell us just briefly about your pathway into this career, and then maybe some of your education?
Yeah, sure. I started out with a first degree in speech communication, and I spent about 7 years working at the Deaf and Blind School in Montana, working as a counselor for the deaf students that were residential up there. And during that point in time, I started to, I got married and was looking at a family and looking at where the career was going at that point in time. In my particular case, when I was going to school the first time around, I took a broad swath of classes. I took some math, I took some physics, I was kind of going all over the place. And so when I got to that point in my 7 years of career at the Deaf and Blind School, I realized that I really wanted to get into the engineering realm. And I was trying to figure out how I was going to do that. And I realized that I had a really good springboard because of all the other experiences that I had in school. And so I took some community college courses up there in drafting, and kind of dipped my foot into the electrical realm a bit, into some classes there, and decided that I really liked that. And my wife and I made the jump to go back to school again. So I spent another 4 or 5 years going and getting a second degree as a kind of a non-traditional student, as they referred to him, and got the second degree at that point, and went around looking for a job, got a job at Evergreen Engineering, and I've been here ever since.
Wow. How many years is that you've been with Evergreen?
30 plus, about 32, I think it is.
Holy
something like that.
smokes.
Yeah.
So, John, what keeps you on board with Evergreen?
Well,
Why a 30-year career?
Evergreen has been a great place to work. Eugene has been a great place to live. In this particular arena, the consulting arena, you can find yourself jumping around a lot, from company to company. And Evergreen has not really been one of those companies that that will, kind of, what should I say? The work ebbs and flows, and as the work ebbs, sometimes you release people and they go someplace else. And Evergreen has strived to keep people on, keep people busy, and it's been a very, very personable company to work for, as well as a technically challenging company to work for also, which has been really fun.
Yeah, absolutely. Thanks, John. And Cody, I remember we did something similar to this, but with for a group of educators instead of students. And
Right.
I remember you saying too that through COVID, you've managed to keep all of your staff intact, and that's very impressive. So,
Yeah, we worked really hard to try and keep people employed, that's for sure.
yeah, absolutely. Derek, you mentioned really liking the consulting side of things and that being kind of a draw to Evergreen, but what else do you love about working for Evergreen Engineering?
Well, I'll echo that what John said. I mean, I think the company is invested, believes in just investing in general, in long-term health of everybody. The company obviously needs to stay in business, so we have to make sure that it's healthy, and we do good work and we get more work. But I think everybody, there is definitely a feeling or a sense that we want every employee to learn and grow, and it's more than just, oh yeah, it's a retention strategy, which it is. But it's, I think it's just a belief, it's a philosophy, I should say. And yeah, it just makes it really fun, and it also helps, I think, keep people connected, because like, if I'm having somebody work on a project for me or with me, and it makes me think, hey, Evergreen's allowed me to say, hey, I want to develop this person in this new way that they haven't worked in this type of thing, but I definitely think they could. It makes me feel more like I can request that, and it makes our team stronger, knowing that there's that ability to grow. And you have to balance that with the schedule. I mean, our schedule is very much dictated by our clients' needs. So if our client needs a drawing or something done quickly, I'm probably not going to ask somebody to do that's never done that type of drawing in 2 days. Probably use somebody different for that. But then thinking ahead about, okay, when we do have some time to develop, we really put a lot of our resources into that.
That's great. And Cody, I mentioned COVID, and I do think it's just so impressive that it was such a priority for you all to keep all of your staff on board. What else changed for you all during COVID? I think that something that the incoming workforce is going to be like hypersensitive to now is this job or is this career path pandemic proof? And so I'm curious just how your all's daily work changed when most people were remote.
Well, it doesn't really address the pandemic proof part of it, but I think that one thing that changed for us is that we had to learn how to work remotely, and so did everybody. But part of it was a kind of twofold. One, how to access all of our data in a way that would work remotely when we're all inside the same 4 walls and server access. The other piece of it was how do we interact and work together remotely, as far as like, because engineering is a lot of dialogue and back and forth and redlining on drawings and talking and pointing to things, and that's harder to do over a screen. And so as we've come back, one thing that's changed for us is that we, during COVID, we've developed a work from home policy. And I think there's pros and cons to that. We allow people to do that are experienced with Evergreen and know the business and have proven themselves here. But I still think there's a lot to be gained by working in the office together, and that communication and those interactions between teams happen better in person than they do over, say, Teams or Zoom. But we're allowing people to do that because it's kind of a new modern thing that you need to, as an employer, you need to have some flexibility in that realm.
Yeah, and I do think truly moving forward that's going to be a big draw for the younger incoming workforce, is the ability or the option to work remotely if needed. Okay, so Cody, I didn't ask you, partially because you're a part owner, but what do you love about Evergreen Engineering?
Well, obviously it's the greatest engineering firm in all of Oregon and pretty much the US, but I started here as an employee as well. And I think that part of what I really like about it is the diversity of the work. We work in a lot of different fields. I like the fact that we have employees here that have a very broad background and have worked in lots of different types of engineering and industrial roles that we get to draw and learn from their experience. And I think I like that we are kind of a small to medium-sized company, so we're big enough that we can take on some big projects, but we're still small enough that we have a personal touch with our employees and everybody knows each other, and it kind of feels a little bit more like a family-run business than a big corporation. So those are some of the things I like.
That's awesome. All right, so I heard OSU talked about by at least two of you. I think we all know that that's a huge engineering school. If you were to encourage students interested in an engineering career, kind of push them one way, what schools in Oregon would you look to?
Well, the MECOP program has, of course, OSU, but there's Oregon Tech, University of Portland, Portland State, are all in the program. And I think they're all good engineering schools. They don't all offer the same degrees. So, some of them have different variations and there is some overlap. And then, there's some private engineering schools out there, and there's obviously the ones out of state too. I mean, UW and Washington State both have strong reputations in engineering. Boise State has a strong engineering program. So there's lots of programs in the Northwest that they all have the ABET. It's called ABET, which I don't know what it stands for, is ABET. It's an accreditation that engineering schools need to get, which helps you get licensed later.
Okay, great. But then for those students that are still in high school, I'm curious, some high schools in Lane County have engineering CTE programs or other CTE programs that kind of dabble in engineering. Mm-hmm. I'm curious, if I was at a school that didn't have those courses or programs, what could I be doing, or what subjects could I be really careful about learning a lot in? What could I do in high school to better prepare me for a career in this field?
John, do you want a chance at first stab at that?
Well, the first thing that comes to mind, of course, is the math, right? Engineering is pretty steeped in math, and it's typically calculus-based math. So you take your calculus route as you're going through school. Physics is a big leg up on the world in general, period, not just engineering. I mean, physics is life skills. That's the way I look at it. And so if you've got a chance to take physics course, take a physics course, because it can be really fun. Of course, you've got the biology aspect of things and all that, and then those are all really good. The one thing that engineers strive for as a rule, and it's very important in what we do, is communication. If you can take a communication course of some sort, writing course, enhance your skills in that, your listening skills, be able to be a good communicator. That's important too. Those are things. The hands-on stuff, if you've got a chance to get into some art, so you visually, I guess you exercise your visual cortex, in creating things, that's also, a help.
Yeah. When Derek was talking about creating like a 3D space or image in your head, I immediately thought back to art classes when you're learning how to draw like a cylinder and a sphere and all those things. So that's great. Thanks, John.
And get out there and play on the playground. Learn what the teeter-totter does in those swings. When you become a mechanical engineer, as I'm sure Derek can attest, you've got a physical feel of the world. You got a leg up on it.
That's a great point. Derek, anything to add?
Yeah, the only thing I would add, I think, is a little bit underappreciated, I guess, would be sort of an economic thing. Not so much. I mean, yes, learning business stuff is fine. I mean, I think that's important. I mean, it's very important in general, but I think it's sort of a if I could design this class for,
Yeah.
I don't know, high school and up or whatever, it would be called, where does stuff come from? How does stuff made? And
Yeah.
how much does it cost?
Oh, that's awesome.
I think, so it's more of the economics of construction in any realm, whether it's industrial or commercial or residential. Just understanding that a lot of efficiency in design, there's a safety element that's obvious, right? We have to make sure that something doesn't collapse or break. But even understanding how things break and what kind of parts, if something's made of one material, how it might be the weakest point in a system, that could be on purpose so that you protect something else, right? Or, so those kinds of things, just how things are constructed and how much they cost and what materials they are. I don't know for classes. I mean, maybe like a jewelry making class or something. I know that I had one of those actually in my high school. I was fortunate to have some pretty good
Cool.
arts and crafts classes, and we did like engine rebuilding stuff, but we also did jewelry making. And I remember a lot of trades and crafts like that. You learn a lot about metals and things like that. So yeah, I'm just trying to kind of think about outside the box a little bit,
No,
but
I like that.
but I
Yeah.
think a lot of people don't appreciate, a lot of engineering is not designed to be just the lightest and greatest thing or the strongest thing of all time. It's designed for its purpose. So if its purpose is to do one thing, how do we do that purpose, but then not spend a ton of money making it over-engineered, making it more design than it needs to be? And that's actually how most things in the world are made. Honestly, I mean, because otherwise it would be impractical. It would be like we're trying to go to the moon with every time we design, a TV or something.
Yep. Absolutely. No, that's great. I'm already envisioning how we can get that class into into high schools.
And to kind of just leverage what both of them said is, I think that if they have the opportunity to take the mechanics class in the wood shop and the metal shop or any of those types of classes, definitely, like John was saying, get out in the world. And some of that's learning to do something with your hands and what is it like and what effort does it take to put into it, to Derek's point. But then if you don't have that in school, look for opportunities outside of school. Maybe you go get a job and you do something in the world. Even, there's a lot of jobs that you can gain some great skills at. But I think kids that get an opportunity to work on a farm or work in construction or do something with their hands really get a leg up in the engineering role.
Yeah, absolutely. And you could even take that into consideration when getting a part-time job. If you're going to work through college or work during high school, you could, choose a part-time job accordingly, especially if you don't have, extra cars or things at home to tinker with. It could be a job in the industry.
If you're a musician, I'm a musician, so I will vouch for, if you want to know about electrical engineering, being a guitar player is kind of helpful.
Okay.
I've learned a lot about like vacuum tubes and transformers and things by having guitar amps and breaking them.
That's awesome. That's super cool. The most I've ever learned in life about just courses of study that I never went into is fixing them when they're broken.
Mm-hmm.
Being at home and our AC goes out or our thermostat goes out. It's the first time I'm ever rewiring anything. But that's the only way. It's the only way to learn. And now with YouTube, I mean, there's nothing we can't do except for build a bridge and do all that.
You can watch some pretty good YouTube videos on bridge building, but
yeah, absolutely. So another thing that high schoolers can do is job shadow. And at Connected Lane County, we do our best to do all the heavy lifting for students and companies that are interested in job shadowing. And so Cody, if we were to send some students your way, what types of careers could they see at Evergreen?
Well, I think they see a lot of what they saw in our tour video, and that we have the multidisciplines with structural, mechanical, electrical, and we have the drafter designers that are there producing the drawings. And then we see the types of work that we work on vary from, we work in wood products plants that are producing plywood and MDF and engineered lumber products. We work in pulp and paper plants. We work in specialty metals plants that are making interesting materials like niobium and titanium and tantalum and things like that, that are in the aerospace and medical industries. And we work for industries that are producing green energy, like biomass power generation and renewable natural gas plants and pellet plants and things like that. So there's lots of those different types of projects going on at any one time in Evergreen, in all these different industries. And then there's all the different types of engineering and drafting going on to put those projects together and give the end client, take their vision and actually turn it into a reality out in the field.
That's awesome. And I know we've sent some students your way in the past. And so is that something that even through COVID, you all are open to doing?
Yeah, we do occasionally. We have to, obviously, like Derek mentioned, we're a consulting firm, and so that every hour is billable. But we do try and invest back in the community. This was, doing these types of events and occasionally hosting a student is welcome.
That's great. Thank you. All right. So before we talk about current job openings, I'm curious. Maybe each of you could either tell me the one misconception that you all have heard about your industry, and or give some students just a piece of life advice as we set them off onto their next steps. So common misconception and or piece of advice. And we'll start with John.
I've got a question.
Yeah.
What do you mean by misconception?
So let me think. Sometimes when we talk about like manufacturing, for example, students picture, big, dark, sterile buildings, and that's just not the case anymore. If we go into modern manufacturing facilities, they're bright and they're light and they're full of energy and hustle and bustle. And so I'm curious if you've heard of any misconceptions about engineering.
No,
They're all pretty accurate.
I'm kind of drawing a blank on that one.
That's okay. Do you have any advice for young folks taking their next step?
Yeah, I guess I've spoken to that. Get yourself out in the world. Start banking your experiences. There's this expression called thinking out of the box. And one of the most effective ways of thinking out of the box is to take all your experiences that you have and look at them. I mean, use them. And the more experiences you have, the more effective you're going to be in thinking out of the box on down the road. Because sometimes, you can have all the math smarts in the world, but if you don't have the creative smarts, then you're kind of disabled in a way. So get out there and get those experiences as much as you can.
Awesome. Thanks, John. Derek or Cody, whoever would like to go next, go for it.
Well, I can go, I guess. I think one misconception is that, you have to be really smart to be an engineer. I don't consider myself the smartest guy in this building at all, but I think you can get through engineering school with, if you have the right aptitude and you work hard, you can get through it. And obviously you're going to have to be able to be decent at math and science to get through that. Another misconception might be that engineers just work in an office and calculate stuff in front of a computer all day. And granted, that's one piece. Like our jobs are a lot like that, but engineers are lots of different roles out in society. There's engineers out in the industrial plants that are out working in the plant and they're process engineers and keeping those processes working properly. They work for contractors as construction managers and project managers out getting the stuff built. They work for a lot, and they could work as sales engineers for somebody that has a technical product and they're out selling that product, but they need to know the engineering side of it. So there's lots and lots of different paths for engineers to and different types of environments to work in.
That's great. Thanks, Cody. And Derek.
Yeah, I'm piggyback off the smart thing. I mean, I think I'd even take it one step farther. I think this is going to sound a little bit controversial. I don't think anything is above hard work. I think that very few things are innate, I guess. You know, we have, our genes are pretty simple. Most of the complexity arises from our conditioning and experiences. So, you know, if you can, you know, see and hear, you can read and write, and with any time you can figure that stuff out. But I do think one thing that is a little bit of a misconception is that I guess it's still kind of similar to what Cody said, but I would just broaden it to say that, like, we have to do a lot of different a lot of actually, like, report writing. I think that's, whether it's even just something in the form of an email, I think technical writing is actually really important. That would be, I guess, rolling into my life advice would be understanding the difference between technical and creative writing. They serve very distinct purposes, and they don't mesh very well together. I'll put it that way. If I'm a creative writer, I want to be as open as possible. And if I'm a technical writer, it's sort of going back to, for the most part, when you're doing a technical writing of any kind, you're writing to an audience that needs to understand something. And so you need to be able to write succinctly and structure the narrative in a way that's very easy to follow, but also boils down a complex problem into a digestible form. And I think that's a big part of engineering. Even if you don't write a lot of reports, you will at some point, or even just your work, you need to think that way. You need to think in a way that you're taking a complex thing and simplifying it. And that is a lot of, I mean, that's hard to do. It takes a lot of experience, but I think rather than just being able to do some big long math problem, engineers need to be able to see what matters within a problem and ignore what doesn't really help to find that answer.
Sure.
And that's sort of a combo of life advice and a little bit of a misconception.
No, that's great. So I heard, get out there and experience things and work hard, and then the engineering world is your oyster. Does that recap it pretty well? So, well, thank you all so very much for being here. We really appreciate it. To those of you who tuned in live, we will see you next week for a tour of Alco Hotel Management. I hope everybody has a great rest of their day.
All right, thank you.
Thank you.
Thanks, Lizzie.
Bye.